Hey guys, section 612 is called inverse functions. Technically, it's called inverses of functions dash the logarithmic function. And we always talk about inverses right after you learn about logs because logs are the inverses of exponentials. You could have learned about inverses when you knew other types of functions, but it just naturally comes right here usually. So basically what an inverse is, algebraically, is a switching of the x's and the y's. So if you have two functions and one of them has all the x's in one or all the y's in the other, and they've just traded places, then those two functions would be inverses of each other. The inverse, if I have a function f of x, the inverse notation would be f to the negative 1 of x. That does not mean put it on the bottom like we usually do with a negative exponent. Usually means 1 over. So if I give you a function, you can't just put a 1 over top of it and that's its inverse. We put that because that 1 over a number is its multiplicative inverse, but this is not what we're talking about here. So this is out. Okay, so the negative 1 exponent is just notation for inverse. So the first thing you need to know is how to find an inverse. And if you go by the definition that it's just the switching of the x's and the y's, that's basically how you're going to find it, by switching the x's and the y's. So to find an inverse, I'm going to start with a function, f of x equals, I'm going to use the cube root of x plus 1. Now, f of x means the same as y, and it's often more beneficial to start with y because we're going to switch our x's and y's, so we need a y there to switch. So just switch them. At this point right here, we have created the inverse. We've changed worlds where this is the inverse. And it's just that we want to solve this inverse for y to make it look like we normally look at functions. We solve functions for y all the time to explicitly define them in terms of y. And so when I've found the inverse. This is it. This thing's graph is the inverse. The change has happened. The transformation has happened. I just want to solve it for y, basically. So if I subtract 1 from both sides, and then the opposite of cube root is cubing, so I'm going to cube both sides. And this is the inverse. So I would write f inverse of x is equal to x minus 1 quantity cubed. And I have found the inverse. Okay? So all my x's have become y's, and my y's have become x's. Okay, so algebraically, it's not a difficult process. You just change the two and then solve for y, and then call it f inverse. Graphically speaking, let me get a little graph here. I need that. I need that. And let's talk about this. Let me get another example. How about f of x equals x squared over 4. Okay, so you should hopefully see that x squared and think, hey, this is a parabola. This is a quadratic function. And its graph, let's just generate a few points and graph it. When x is 0, y is 0. When x is 2, I get 2 squared is 4, 4 divided by 4 is 1. So at 2, my height is 1. At negative 2, my height is 1. How about at 4? At 4, I'm going to be going through 4, 4, because 4 squared is 16, divided by 4 is 4. So we can start to get the idea. Negative 4, 4. And if I can get another good point, what if I plug in, I don't know if another one will fit. If I plug in 6, then I get 6 squared is 36. 36 divided by 4 is 9. So 6, 9 will work. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 9. And negative 6, 9. This is what's called an even function. because it's symmetrical about the y-axis, and those happen usually when the exponents are even. That's not what we're on right now. We'll get to that someday. Okay, so here's the graph of f of x equals x squared plus 4. Okay, so this function's inverse, which you could call g or you could call it just f inverse. If I switch my x and my y, I get x equals y squared over 4, and then I get 4x equals y squared. Then I square root both sides, and then I get plus or minus, because when I square root y squared, I'm going to eliminate half of my answers if I don't do this plus or minus. Plus or minus the square root of 4x equals y. And I can get that 4 out of there and make it plus or minus 2 times the square root of x equals y. So that's just another example of finding an inverse, and I just want to show you what this graph looks like. So plus 2 times the square root of x. All points are going to be reflected across the line y equals x. So here's y equals x. And I want to make it a little less prominent. So there's y equals x. Every point in that red graph needs to be reflected across that line. And then I will have the graph of plus and minus 2 times the square root of x. So I'll keep working in green. This point, the origin, happens to be right on the line. So when you reflect it, it doesn't move. The point 2, 1 becomes the point 1, 2, because I actually reverse the x and the y. Back here at 4, 4, I'm on the axis again. This point was, right here, was 6, 9. That's going to become 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And you can see it just goes in a straight line reflection right across the line y equals x. All the points do it. Negative 2, 1 is going to become 1, negative 2. And negative 4, 4 is going to become 4, negative 4. And negative 6, 9 is going to become 9, negative 6. All of those points go straight across the line y equals x. That's the graphical interpretation of what happens when you switch x and y. When you find inverses, you flip your graph over that line. And one of the questions your book problems will ask you is the inverse a function? And because we've included the plus or minus version in our inverse, it's not a function. The plus version is this top part of the sideways parabola up here. The negative version is this part of the graph down here. Because both of those are included, when they should be, because I need to flip my entire graph over the line y equals x, the inverse itself is not a function. So sometimes a function's inverse is another function, and sometimes it's not, because this green sideways parabola severely fails the vertical line test, so it is definitely not a function. So back to the beginning. To find an inverse, switch x and y, solve for y. Graphically, a function and its inverse will be the original function and its reflection across the line y equals x. Point by point, every single point gets reflected across that line. This point goes here. This point, where do we go? This point goes here. Some of them are going left to right. Some of them are going right to left. This point goes here, and so on. Every single point, the whole way, reflects across that line. The last thing you need to know is, how do you see two functions and determine, are those two functions inverses of each other? Okay, so for example, this section is called hi, are you my inverse? To check that, I'm going to do something like this. In this example, f of x equals x to the 5th, and g of x equals 5x. You might look at those two and think, hey, yeah, those are inverses. They look similar, but there's some differences. If two functions are inverses, then f of g of x will equal x. And we talked about plugging an entire function into another function earlier. And g of f of x will also equal x. This is the case if f and g are inverses of each other. So to check, plug in one for the other and see if it reduces down to just an x. F of g of x would be 5x to the fifth power. You can see how I took the entire g function and substituted it in for x in the f function. So 5x to the fifth power, that's not going to reduce down to just an x. I've got 5 to the fifth, which I don't even know what that is. Let me check here. 5 to the fifth power is equal to 3125. And then the x gets the fifth power as well. So this is not equal to x. So no, f and g aren't inverses. If we were to do this check and get x as our answer, then we would have inverses. So let me just use this previous example. Let me use my first example. Let's go do a quick inverse check. What is, and I've called it f inverse here, so I'm going to rename it g of x real quick. Call that g of x. So f of g of x would be take the f function, which was the cube root of x plus 1, and instead of x in that function, I'm going to put x minus 1 cubed, and then do the plus 1. So this is f of g of x. Cube rooting and cubing cancel each other out, and I'm just left with x minus 1 plus 1, which is x. And you can kind of see how the parts just cancel each other out if two functions are truly inverses. And the only thing left is x. So it's the calculations here are the steps algebraically are usually not too confusing. So a quick recap. We have 3 ideas today. How do you find an inverse? You switch the x and y's, solve for y. Graphically, inverses are each other's reflection in the line y equals x. Because if you think about it, all the x becomes y's and all the y's become x's. So a point like 6, 9, if you switch x and y, will become a point like 9, 6, or vice versa. And finally, how do you check and see? Are you my inverse? Plug one entire function into the other, and if everything just undoes itself and you're left with an x, then you know your two functions were inverses. And I know I started this by talking about logs, so just a quick thing about logs before we're done. The reason that we are talking about this right now is because two things like exponentiating and logarithming, logging, are exponents of each other. In class the other day I showed you a problem, log base 10 of 10 to the goat equals goat, something like that with those goofy pictures. But logging and exponentiating are inverses. That's why log base 10 of 10 to the x equals x. Because the action of raising 10 to this power and log base 10ing this thing undo each other, just in the same way that x plus 2 minus 2 is x, because plus and minus, and x times 2 divided by 2 is x, because multiplication and division are inverse operations. The square root of x squared equals x, because square rooting and squaring are inverse operations. In that same way, log base 10 of 10 to the x equals x. Really concentrate on learning what these logs mean. All the way through pre-calc and calc, people always seem to have a trouble interpreting what log means. It's just exponentiating backwards. So if you can get that down, you'll have a leg up on the competition. All right, so I will see you in class. Young out.